Okay, so we just used Cramer's Rule to solve a 2 by 2 linear system. Now we're going to use it for a 3 by 3. 3 variables, x, y, and z. Maybe you'll like this more than the substitution method or the elimination method. I don't know. Let's just see. Okay, so this is going to get a little bit crazy. So of course we're going to have to find determinants of 3 by 3 matrices. You want to first find the coefficient matrix. So just like with the 2 by 2, we're going to have to divide each of these fractions by the determinant of the coefficient matrix. So you find that by just taking the coefficients of each one of the equations. Okay. So now, if I want to find the x's, remember what we did with the 2 by 2? Here it's exactly the same. If I want to find the value of the x, I take the coefficient matrix. It's going to go up top, but I take the x's out. And I replace it with the constants j, k, and l. Okay? Find the determinant at the top divided by the determinant of the coefficient matrix. For the y, again, I'm going to put up top the coefficient matrix, but I'm looking for the y, so I'm going to take the y's out and replace it with the constants j, k, and l. Okay? And then finally for the z, coefficient matrix up top, but take out the column of z's and replace it with j, k, and l. All right. So let's try to use this then to solve a 3 by 3 system, see if you like it. And to speed this process up a little bit, let's use the calculator. Okay, so if you have your calculator, you want to get that thing out, or turn on your emulator or whatever. So I'll show you how to find a determinant in the calculator very, very easily. Okay, so what I want to first do is find the determinant matrix. So I want to find, this is the coefficients. This time I'm just going to go down in columns here. So not a 4, a 3, a 4, and a 2. There's all the x's. And then a -4, a 1, and a -3. And then going down, I have a 2, a -5, and a 1. So let's first find that. Let's pull up this calculator here. I'm going to have to do this, of course, on the matrix menu. So to get to the matrix menu, remember that is second, x -1, and then it pulls up the names of all the matrices. Okay, we need to scroll over to edit. Let's just choose A, and this is going to be a 3 by 3 matrix. So type in a 3 by 3.
Okay, and now just type in your numbers just like you see them there for the coefficients. 3, a -4, 2, 4, 1, -5, 2, what? Freaking 2. Oh, man. That is a -5. It must not hit there. 2, -3, and a 1. Okay?
So now we're going to quit out of this menu. And in order to find the determinant, we'll go back to the matrix menu. This time I want to go to the middle column where it says math. And look right there. Number 1 says det. That's the determinant. I'm going to choose that one. Inside there I need to put the matrix A. So that's back under the matrix menu again. Matrix. And then hit enter on the first one. You can close the parentheses, but you do not have to. It's not necessary. And then hit enter. It's -14. Okay. So I know the determinant of the coefficient matrix here is -14, which means I have a unique solution, and that's what I'm going to divide each one of my x, y, and z coordinates by. Okay, so for the x, that would be equal to coefficient matrix formed by, I'm going to take the x's out and replace it with 18, -13, and 11, and then the rest stays the same. -4, 1, -3, 2, -5, 1, and this is all going to be divided by 14. So let's just pull up the calculator again and go back to the matrix menu. Second y equals, second x -1. Okay, and let's just edit, scroll over here to edit, and put in, let's edit A, okay? Edit A, it's still 3 by 3. I'm just going to go down here and take out the 3, the 4, and the 2 and put 18. Instead hit enter, hit down, -13, hit down, and then 11, Now I can hit enter on that one. Okay, if I quit out of this, now I do not have to call this thing back up. I don't have to type it back in, so I already have determinant of A in there. So if I just hit second, enter, that's the last entry. I hit enter again, I get negative 28. Okay, so x is equal to negative 28 divided by 14. Oh, negative 14, it was negative 14. X is equal to 2. I have my x coordinate, right? Now let's find the y coordinate. Y coordinate, I'm not going to write anything down here. I'm just going to know that I'm going to take out the y's and put in the constants. I'm just going to do it straight in the calculator there. Okay, so let's go back to the matrix menu. Over here to edit. This time I'm going to have to replace the x's again.
So a 3, a 4, and a 2. Okay, so I just replaced the x's with what they used to be, and now I'll replace the y's with 18, scroll down, negative 13, down, and 11. Enter. Quit out of this. Second enter. On the determinant of that, it's 14.
Okay, so here I got 14 divided by negative 14. My y is equal to negative 1. Done. At this point, you could do z exactly the same way, or you could just plug x and y into one of the equations and solve it for z. Let's just get the practice one more time on the calculator.
Go into the matrix menu. Edit A. Okay, we're going to have to replace the y's with what they were supposed to be, so negative 4. Down, 1, down, negative 3. Enter, let's scroll back up here, take the z's out and put 18, down, negative 13, and 11. Okay, quit out of this, second enter. Find the determinant of that, it's negative 56.
So, my z coordinate is negative 56. It was negative, right? Yeah. Divided by negative 14, and that's going to be a 4, positive 4. So my answer here is 2, negative 1, 4. Ta-da! Why don't you give that a try, right? I know you're aching to. Why don't you give that a try on this system of equations? Use Cramer's rule. You can use a calculator to help you out and find the solution x, y, z. So, how did you like this? Did you like it more than elimination? Did it take a little bit less paper? Okay, so again, what you first want to do is find the determinant of the coefficient matrix, and you get 1. You get a number 1, that means that you have a unique solution. We're going to divide each one of our fractions by 1, which is a real nice number to divide by. Okay, so for the x's, I take out the column of x's, replace it with the constants negative 1, 1, and negative 2. Find the determinant, divide it by 1, I get 2 for my x value. Do the same thing with y's, take out the column of y's, replace it with negative 1, 1, negative 2. Find the determinant, divide it by 1, I get negative 1. Finally, for z's, take out the column of z's, put in negative 1, 1, negative 2, and find the determinant, I get negative 2. So there's your solution, 2, negative 1, negative 2. That's using Cramer's rule to solve a system of equations with 3 variables. And I know you're probably going, why didn't you just teach us that to begin with? Well, would you really, really understand this method? Would you appreciate it if you didn't do that other method beforehand? And you're probably going, yeah. Anyway, so that concludes our lesson on determinants. Find a determinant of a 2x2 and a 3x3 matrix. Also using that determinant to find the area of a triangle in the coordinate plane. And also using Cramer's rule, as you can see in the picture right there, to find the solution to a linear system with 2 variables or 3 variables. That picture there gives me another idea for an extra credit assignment. Well, anyway, here's your assignment, and I'll see you in class.